Hi everyone. We are going to talk about negative staining. This is Manuel. We are from the group 5 with Luis, Marcela, Maria, and Maria Rita. Electron microscopy negative staining was first described by Brenner and Horn in 1965. It's a procedure using transmission electron microscopy technique, which is incorporated a thin and amorphous film with heavy metal salts to highlight small biological particles in an electron transparent simple support, what we call grid, to a better review of their structural details. It consists in the involvement of a biological elements by an electron-dense medium, usually, as I said, heavy metal compounds. So their images are presented as a negative contrast. So biological elements become clear, more transparent to electrons compared to the bottom or the background of the preparation. So the electron beam of the microscopy of the electron microscopy can cross biological material easier than the surrounding space. As you can see here, this is the side view of our preparation. And then we have the top view of the preparation, which is a unstained or non-stained specimen. So here we can see the grid, which is the background with a thin carbon film on it. And here we can see particles. So in the top view, now we can see particles in the background, very blurry and shady. So we can tell exactly the difference between the biological particles we want to see, and then the background and the noise or artifacts. So, sorry. When we negative stain this preparation, we stain the background with the heavy salts. So now with in the top view, we can see the edges of the particles, and we can see exactly the structure of our biological sample. Talking about the applications, we can use this technique in a research, as a research tool, as a diagnosis tool, and in nanotechnology. With variation of the technique, of course, it can be applied widely to spread biological samples types, ranging from viruses to single macromolecules and macromolecules assemblies, subcellular membrane fractions such as membranes, organelles, mitochondria, cytoskeletal structure, lipid suspension, and toxin lipid membrane interactions, and so on. So we can use this technique to see and to study a lot of things. I brought here some examples of things we can use in transmission electron microscopy with negative stain protocol. So here we can see the bacteriophage, which is a virus that parasite bacteria. So here we can see the virus more white and clear with the shady edges and the background stained. We can see the hepatoviruses that we see here the type of colony, the hepatovirus that causes the hepatitis type A. We can see bacteria too, the structure of the Vibrio cholera. And here we can see the mycoplasma, which is another type of bacteria that usually contaminates cellular cultures. It's a young age of mycoplasma, which is very small. We cannot see with microscopy, optimal microscopy. And here we have also like a huge macromolecule, which is the collagen type 1 of rat tail. So we can have this type of technique with a lot of things. This techniques stain protocol is were revised and improved many times throughout history and used to assess the and suit better its specific biological samples. So we have a lot of type of reagent with different sources of heavy metals. So we can use different type of heavy metals with different concentrations and pHs and different charges with anionic and cationic charges. So depending on the type of material you're trying to look, you have to understand and study what type of reagent and what type of heavy metal salts you're gonna need to use in what concentration and pH, what suits better. Here about a table that have like different types of reagent with concentration and pH in different types of viruses. It's a one class of living, but here we can see the difference between the successful of the technique in comparison between different type of viruses. So here we can see a PTA with the pH 8 that is suits for rotaviruses, but it doesn't suit for adenovirus. So we have to look what type of biological sample you're trying to understand and choose a better type of stain protocol. Here about also an example, tobacco mosaicovirus stained with virus negative stain reagent. So here it's a uranium, the A, it's a uranium type of stain. And then we have a different type of heavy metal salts. As you can see here in A, it's a very clear picture. But when we see the F picture, we can see everything is blurry. We cannot see the viruses. We cannot see a lot of difference between the background and the biological sample. So we need to know that what type of virus or biological sample we are trying to use to choose the exactly heavy salt with exactly concentration to be successful. The general preparation steps are usually the preparation of the grid first, which is a support film, must be transparent and mechanically stable during procedure, and the electron beam, which is usually a copper grid with carbon film. And then we have the pretreatment, which is the hydrophilic suspension must be spread on the plastic film on the grid to allow absorption of the particles. And the particles should strongly adhere on the grid surface during the further process. And then we have the washing step with the removal of the salts and macromolecules, which might interfere with the staining or visibility of the particles. The first step is the staining itself. The heavy metals stain should protect the sample structure from collapsing during drying and should provide contrast to the detection and the structural features, which is exactly the aim of the technique. And then we have the microscopy, finding, recognizing the relevant particles. I'm going to play a video very quickly so we can see how it works in practice.
If you perform this in a microbiological safety cabinet or fume hood, the grid may dry out faster. There is a separate video for preparing a higher biosafety level sample. Before you begin, gather the materials you need, which are pictured and listed. If your grid is not hydrophilized, see the previous video on sample preparation, grid glow discharge. First, mount a hydrophilized grid onto the inverted tweezers. This enables the grid to be stable during the entire procedure. Be sure the carbon side of the grid is facing out. Place 3 microliters of the sample on the grid. It is important during this process to keep the grid wet so that it does not dry out. After waiting 60 seconds, blot the excess of the sample with a wet blotting paper. Immediately after blotting, place 3 microliters of ultra-pure water on the grid and prepare a pipette with 3 microliters of stain. Then blot the excess liquid from the grid with a wet blotting paper. Immediately after blotting, place the 3 microliters of stain solution from the prepared pipette on the grid. Wait approximately 10 seconds and then blot the excess of the sample. There is an alternative method for the washing step. This alternative washing method can be used for VLPs or lentivirals to remove more debris. Place 3 drops of ultra-pure water on a parafilm. Also, place a drop of stain on the parafilm. Slide the grid on top of each water drop and blot off the excess liquid after each drop. Slide the grid on top of the stain, wait 10 seconds, and then blot off the excess liquid. Finally, store the prepared grid in a grid box until you are ready for imaging. If your grid appears to be sticky, this can be caused by an excess of sample. Next time, prepare the grid with less sample. This completes the sample preparation by negative staining.
So now we saw the preparation of the protocol, and as an apply example, we brought here this article that was published on the Journal of the Applied Microbiology. So this title is Detection of the Limit of Negative Staining Electron Microscopy for the Diagnosis of the Bioterrorism Related Microorganisms. So the group from Germany, they proved that this is a very values type of technique that they can use for diagnose microorganisms from episodes of bioterrorism related situations. They show that this technique is very reproductive and very sensibility, has a wide sensibility to understand and to diagnose this type of events. So we're going to send to you guys the link of this article. Is very rich. So here these are references. Thank you. We appreciate it very much.